Hello students, this is our 7th lecture of lesson number 2, that is mechanical properties of fluids. I am Kirti Patil from SR Patil Junior College, Akola. In this lecture, we have to see what do you mean by surface energy and relation between surface tension and surface energy per unit area. At first, we have to discuss about surface energy. When a molecule is taken from the inside to the surface layer, work is done against the inward resultant force. While moving up in the layer, the potential energy of the molecule is increased due to this work. This extra energy a surface layer has is called the surface energy. Since the units of surface tension and surface energy are the same, so numerically we can state these two quantities are same. Now next we have to seen here a relation between surface energy and surface tension. Question on that topic is, that is, derive the relation between surface tension and surface energy per unit area, or show that the surface tension of a liquid is numerically equal to the surface energy per unit area. At first, in this diagram, we have to consider ABCD be a rectangular frame of wire fitted with a movable arm PQ. The frame held in horizontal position is dipped into soap solution and taken out so that a soap film APQB, है ना, see carefully in the diagram, APQB is a form. Due to surface tension of soap solution, a force F will act on each arm of the frame. Force F will be acted on each arm of the frame. Under the action of this force, the movable arm PQ moves towards AB. Magnitude of force due to the surface tension is F is equals to twice T 2TL. That is, factor 2 appears for two films, one above and the other below the frame. Let the wire PQ be pulled outwards through a small distance dx. That frame PQ, that wire फ्रेम PQ ची वायर जी आहे PQ ती आपण आउटवर्ड डायरेक्शनला ओढणार आहे, पुल करणार आहे. दॅट मीन्स देअर इज चेंज इन सम डिस्प्लेसमेंट, दॅट इज dx टू द पोझिशन P डॅश Q डॅश. मग ही वायर PQ आपल्याला पुल केल्यानंतर आपल्याला P डॅश Q डॅश मिळेल, है ना, and there is some distance change in small distance, that is dx. By applying an external force here isothermally, which is equal and opposite to F, work done by this force, that is, work is equal to force into displacement, that's why here we have getting 2TLx. But twice T L twice Lx is equal to area A here created, that is increase in area of two surface of films. Therefore we can say that W is equals to TA, and work done is equal to surface tension into that area. This work is stored in the film in the form of potential energy E. That's why we can say that surface energy E is equals to T into A. Hence we can say that surface tension is equals to surface energy per unit area. Thus surface tension is equal to the mechanical work done per unit surface area of the liquid, which is also called as surface energy. Potential energy stored in the liquid surface per unit surface area is called as the surface energy. This is the relation between the surface energy and surface tension. Then next, here we have to discuss one example, that is a beaker of radius 10 centimeter is filled with water. Calculate the force of surface tension on any diametrical line on its surface. Surface tension of water is 0.075 Newton per meter. Here you have given, that is L, that is the 2 L is equals to 2 into 10, that is 20 centimeter, is equal to 0.2 meter. बिकर हॅव्हिंग रेडियस दिलेली आहे तुम्हाला 10 सेंटीमीटर, त्याच्यावरून आपल्याला त्याचा डायमीटर घ्या, म्हणजे त्याची लेंथ घ्यावी लागेल. देन टी इज इक्वल्स टू 0.075 न्यूटन पर मीटर. That's why T is equals to F by L, and here F is equals to T into L, and we have to calculate this value. We are getting force is equal to 1.5 into 10 raised to the power minus 2 Newton. Then next one problem is calculate the work done in blowing a soap bubble to a radius of 1 centimeter. The surface tension of soap solution is 2.5 into 10 raised to the power minus 2 Newton per meter. Here we have to calculate work done. And for work done we have to know that formula, work is equals to T into A, surface tension into area. Here you have to given T, that is 2.5 into 10 raised to the power minus 2. Initial radius of bubble is 0 centimeter. है ना? Final radius of bubble is R is equals to 1 centimeter is given here, that is 0.01 meter. Initial surface area of soap bubble is also is equal to 0. है ना? A soap bubble has two surfaces, outer surface and inner surface. Therefore, final surface area of soap bubble is A is equals to 2 into 4 pi r square, that is 8 pi r square. That is change in area is equals to dA is equals to A minus 0 is equal to 8 pi r square is equal to 0.00251 meter square. Then we have to calculate here work done. Work done is equals to T into A or dA, that is, again we have to put that value, and we are getting the answer 6.275 into 10 raised to the power minus 5 joule. Then next, some questions are given here. Can you recall question that are given on page number 33 in your textbook? But one question is, this is in your question bank question, that is, why is the surface tension of paints and lubricating oils kept low? Surface tension of lubricating oils and paints is kept low in order to help them spread over a large area. Then next one is, you must have blown soap bubbles in your childhood. What is their shape? Soap bubbles are spherical in shape. Then next is, why does a grazed razor blade float on the surface of water? The free surface of water behaves as a stretch membrane due to surface tension. When a grazed razor blade is placed on the surface of water, the vertical component of the force of surface tension acting on the razor blade balances its weights. This helps the grazed razor blade to float on the surface of water. सरफेस टेन्शनच्या इंट्रोडक्शनमध्ये आपण वॉटरमध्ये ती पिन फ्लोट होताना आपण बघितलं होतं. तसंच या क्वेश्चनमध्ये तुम्हाला विचारलं आहे की जे रेझर आहे ते रेझर त्या लिक्विड सरफेसवर कसं फ्लोट होतं आहे, आणि बिकॉज ऑफ ड्यू टू दॅट कॅन बी फ्लोट विथ द हेल्प ऑफ सरफेस टेन्शन. Then next one is, why can a water spider walk comfortably on the surface of still water? आपण याचं पण पिक्चर याच्या पूर्वीच्या व्हिडिओमध्ये बघितलेलं आहे. द फ्री सरफेस ऑफ वॉटर बिहेव्ज ॲज अ स्ट्रेच मेम्ब्रेन ड्यू टू सरफेस टेन्शन. जे रेझरचं रिझन आहे तेच रिझन या स्पायडरच्या आन्सरला सुद्धा तुम्हाला देता येईल. व्हेन अ वॉटर spider walks on this surface, the vertical component of the force of surface tension acting on the spider balances its weight, helping the water spider to walk comfortably on the surface of the still water. या दोघांचा आन्सर तुम्हाला सेमच देता येईल, फक्त कन्सेप्ट तुम्ही लक्षात घ्या. Why are free liquid drops and bubbles always spherical in shape? Due to surface tension, liquid tries to acquire minimum surface area. For a given volume, sphere has minimum surface area. Hence, free liquid drops and bubbles are spherical in shape. Then next one is how much amount of work is done in forming a soap bubble of radius r. This is a question bank question. Work done against force due to surface tension, that is W is equals to T into dA. In case of bubble of radius r, there are two surfaces in contact with air. Therefore, the total surface area of bubble is given by dA is equals to 2 into 4 pi r square is equal to 8 pi r square. Thus, the work done in forming the bubble is given as W is equals to T into dA is equal to T into 8 pi r square is equal to 8 pi r square T. आपण याच व्हिडिओमध्ये जे एक्झाम्पल बघितलं ते याच फॉर्म्युल्यावर बेसिस एक्झाम्पल आहे. Why two or more mercury drops form a single drop when brought in contact with each other? The surface energy of a single drop form is less than the total surface energy of the small drops. As every system tries to attain a state of minimum energy, the drops of mercury, when brought in contact with each other, form a single drop. These are the some questions which are given in your textbook. Can you recall section? Okay, thank you, students.